Okay, so we're going to walk through an example of how to do a momentum collision equation. And I'm going to take it like in very small steps to hopefully help you guys. So a basketball has a mass of 0.625 kilograms. So I'm going to use orange because basketballs are orange. And I'll write 0.625 kilograms. I always recommend going through and figuring out what is the actual information in the question and then how do we use it. And just kind of take it step by step, like I said. So that's a mass. We're going to say basketball. That's the first thing we're talking about. So I'll say M1. Kobe throws the basketball into the air at 15 meters per second. So 15 meters per second. And we know that meters per second is going to be, that's a velocity. So I'll put V1 because I'm still talking about my basketball. Okay, so there's information about the basketball. Now we also have a baseball. So I'm going to use red to represent my baseball because they have the little red stitches on them. So baseball has a mass of 0.125 kilograms. So I'll write that right here, 0.125 kilograms. And that's going to be mass 2. So, because that's second object, right? Clayton throws the baseball at the basketball with a velocity of 45 meters per second. So 45 meters per second equals, that's a velocity, and it's the second object we're worried about, so it's going to be V2. The two balls hit, and then the basketball bounces back at 10 meters per second. So let's come over here and get orange again, and we're going to say 10 meters per second equals, well, what is it? It's a velocity, so it's a V. Number 1, we're talking about because we're talking about the basketball. But look at this, we can't have two V1s here, right? I have two different numbers that both mean V1, so they got to be a little bit different. And the difference is that this one is before they hit with each other, before the two balls hit, and this one is after. So V1B and V1A. And I know that looks pretty complicated, but I mean, it's just a little label to help us keep track of what's what, right? And so then it says, what is the velocity of the baseball after the collision? So velocity of number 2 is the baseball. A for after, and we don't know what that is. That's our question, right? So that's what we got to find out. And the way we're going to find it out is by using what we know about momentum. And so what do we know about momentum? Well, we know that we use a lowercase p to represent it in our equations. And we know that momentum depends on the mass, so how heavy something is, one way to think about that, times the velocity, so how fast it's going. So a big, heavy thing has a lot of momentum. A small, slow thing, or a light, slow thing, does not have very much momentum. We also know that if I have more than one object, I can just add their momentums together, and that will tell me the total momentum. Sorry, I'm trying to write small here so we can fit this whole thing without having to scroll down or anything, so we can still see it all here. And then the last thing we need to think about is that the momentum before a collision has to be equal to the momentum after. The total momentum before and the total momentum after have to be the same. That's like a big deal in physics. So long as we don't lose any energy, the momentum has to be the same. And we haven't learned too much about energy by the point we're learning this, so we're going to assume that we're not losing anything. Momentum is going to stay the same. Total momentum stays the same. Okay, so now what we're going to do is we're going to combine all three of these equations into one. And so I'm going to take my momentum before, but I have two different objects that have momentum, right? And so the momentum for each object is going to be the mass of the first object times the velocity of the first object, plus, so that's like this one, right? So here we went, combine this into here. Now we're going to take this into here. So the mass of the second object times the velocity of the second object. So that's all of our before. Equals, well, after is just going to be kind of the same thing, right? So M1 V1 plus M2, V2. The difference here being that these are before and these are after. Okay, so we've got lots of colors here. We've got lots of equations, lots of numbers. We're going to kind of combine it all together into one thing. And I just got an email. Hooray. So let's take this equation here, this big long one that we just wrote, and we're going to plug in each thing from the word problem. So M1 is the first thing we need to worry about right here. M1 is going to be, we said, 0.625 kilograms. So I'll write that right here, 0.625 kilograms. And my dog is freaking out about something. Hopefully he shuts up in a second. So 0.625 kilograms times. Okay, next up is V1. And this is before. So that's going to be V1B is 15 meters per second. All right. Plus. Okay, M2 is 0.125 kilograms. Oh, and I need to switch to red for this because we're talking about baseball now. So there's my parenthesis. 0.125 kilograms times V2 before, we forgot to write that here, but this was V2 before, is 45 meters per second. Okay, so this takes us up to this point of our equation here. Then we have an equals sign, or back to M1 over here, but now we're talking about after. So let's get back to orange for the ones. M1, okay, the mass stayed the same, right? So the basketball didn't change mass. Mass almost always stays the same. Unless you're like sticking two different things together or splitting it apart or something. So anyways, 0.625 kilograms times, okay, V1 after, that's V1A for V1 after, is 10 meters per second. 10 meters per second. Okay, plus, now we've got, for number 2, or M2 after, so, okay, mass is still the same, so the mass of the baseball didn't change, 0.125 kilograms times, we are almost done with this step, V2 after, well, we don't know what that is, so let's just write that as V2. Okay, so V2. We can say V2A, just to be clear. Okay, so take a deep breath. That's the hardest part, is getting to where we are right now. And it's not hard, it's just there's a lot to do and a lot to remember how to fit this and that together. So the good news is that we're done with that. And so now what we're going to do is start putting these things into our calculator and see what we get. So here's my calculator. I'm going to try dragging this over here. Oop, not full screen. Okay, I'll just have to keep it there for now. Okay, so 0.625 times 15. That's pretty easy. Let's clear this all out. We have 0.625 times 15 equals 9.375. Okay, so let's write that down here. Go back to orange for our basketball. And I said that was 9.375. What are we talking about? Kilogram meters per second. Okay. Kilograms meters per second. Okay, that was easy. That's not quite the same color orange, but you get the idea. Let's do the next one here. So this is going to be in red, though, because we're talking about the baseball. 0.125 times 45. So I come back to my calculator. 0.125 times 45 equals 5.625. Okay, so I come down here. So this is plus 5.625, and that's still kilograms times meters divided by seconds. So kilograms meters per second equals. Okay, so now we're back to basketball. So I'm going to switch back to orange. I know you guys are probably just doing this in pencil, so you don't have a bunch of different colors. That's totally fine. I'm just doing this to help us keep track here. So now look at this, 0.625 times 10. Sure, we could go punch that into our calculator if we wanted, but anytime you're multiplying by 10 or dividing by 10, you're just moving the decimal either to the left or to the right. So since we're multiplying, by 10, it's going to get bigger. So 0.625 is going to become 6.25. If you don't believe me, punch it in your calculator and check. So again, that's kilograms meters per second. Kilograms meters per second. Plus, and then the only thing we have left is this 0.125 kilograms times V. So let's just write that. We can't really do any, oops, and I need to be in red. We can't really do anything with that number, with those numbers yet. So plus 0.125 kilograms times V2, and I'm trying to sneak this in beside the little picture of me. Okay, there we go. That wasn't too bad. That was just kind of some plug and chug, right? Plug it in the calculator and then write it down. And if we look, we got good news here. So if I look at the units for everything, I got kilogram meters per second, kilogram meters per second, kilogram meters per second, kilograms times velocity, and velocity is going to be meters per second. So that means everything is like the same kind of thing, so we can add them all together, no problem. And so I don't really know what color to use now. I guess I'll stick with blue because now we're going to combine them, right? So again, I'm just going to punch this in my calculator, just kind of combine like terms, as we say. We got 9.375 plus 5.265. So 9.375 plus 5.625 equals 15.025. Okay, let's write that down. And our units are still the same. So we have 15.025. And my pen's going crazy. Those are still kilogram meters per second. Equals. Okay. Now, over here, we can't really combine them, right? So we could just write this down again, but what we're going to have to end up doing is start thinking about algebra. I want to get V2 by itself, which means I got to get rid of everything else, and we've got to kind of work our way from the outside in to get it there. So I need to get rid of this 6.25. Since they're being added right now, I want to do the opposite of adding, which is subtracting. So I'm going to subtract 6.25 from both sides of my equation. Actually, I'm kind of doing this in a little bit weird order just to try to save space. But I'm going to go ahead and subtract my 6.25 right here. And let's find out what that is. Okay, we already have that number there. Minus 6.25 equals 8.775. Okay, lots of decimals today, but that's okay. So we have 8.775, I think was right. Yes, okay. Equals, we kind of skipped this step here, but that's, like I said, I'm trying to save space. Equals this 0.125 times V2. And I guess I'm just going to abandon colors now. 0.125 kilograms times V2. Yes, this is still, we have the same units, right? Okay, so now, like I said, we're trying to get V2 by itself. I got to get rid of that 0.125. And right now it's being multiplied. So to get rid of multiplying, what I'm going to do is divide. So I divide both sides by 0.125. And those are kilograms. And I'm going to do the same thing over here. So divide by 0.125 kilograms. And I left my units off up here. This is kilograms meters per second. Sorry, that's getting real sloppy, but you get the idea. All right, we have our 8.775. I'm going to divide that by 0.125, and that equals 70.2. So that means that 70.2, and we're left, we had kilograms, gone right there, gone over here. So we're left with just meters per second, which is good because we are talking about a velocity, and velocities should be in meters per second. So that's the velocity of our baseball after the collision. Now, a little side note here. I just made up these numbers for this question just for an example. Everything made sense. These are all 45 meters per second. So that's a pretty fast ball. These are the right masses for these, 15 meters per second. That's a good throw, but it's, this all makes sense. 70.2 meters per second. That's a real fast moving baseball. So maybe when they bounced, it just flew off. Super crazy fast. And so, like I said, I didn't do an actual experiment to figure this out. I just kind of gave you some numbers here. And maybe that would be a test we could do later. So this was a really long video, but I wanted to go through everything step by step, and this should really help you on the quiz. Most of the questions are very, very similar to this. You're going to use the same equations, set things up the same way, solve the equations the same way. You should be fine. Okay, the only one that's a little bit different is where you have the two lumps of clay stick together, and then since they're stuck together, they have the same velocity. So it's actually easier because you can add all your components on the right-hand side. If you do have questions with that, reach out to me one way or another, and I'll see if I can help you get it. But you got this. Good luck, and I look forward to grading your work.